Hey guys, what's up? Today I will talk about the publisher subscriber design pattern and see what this pattern solves. To do that, we're gonna begin with the traditional way of doing things, the request response model. You see to the left, we have a desktop UI creating an order. That order is received by a specific ordering service at the back end. It does the necessary validation processing logic. Then that order needs to process some payment, right? So it calls a separate service running at the back end internally, responsible of submitting a transaction to the external payment gateway. Once that order receives the response, it updates its own database. That's the happy path. But what can go wrong in such setup, guys? First, that payment gateway can take time to respond, leading to the payment service waiting for that transaction, consequently the ordering service as well. That is blocking calls, leading for the user to keep waiting on the UI side for a confirmation. Bad user experience. Another thing that can happen is that this payment service can go down, leading to that ordering service waiting for that payment service to go back live, and the same effects can happen. Plus, even that payment gateway external one can go down. Even if you implement your own retry logic in the ordering service, the whole pipeline will stop responding, leading to cascading failures in the system. That's the main problem. You do have a single point of failure in this kind of setup. Once something wrong or something unexpected happens, even the network can go offline temporarily. Some network glitch there. There are several things when dealing with distributed systems you need to take care for or take into account. All right, that payment service in reality doesn't only talk to an external payment system. In real systems, this is what happens. So you have the same setup here, but in reality, the payment service gonna call the external payment system. Then, in a sequential fashion, in this request response model setup, it will send that transaction reference received from the external system to a software as a service used by that enterprise for sales record. And finally, it will call a local SMTP gateway or an external API to send a confirmation email for the corresponding user here. So you see you have several steps before returning the response to the ordering service that is still waiting for that payment service to return the response there. So in each of these steps, you can see there could be a glitch, there could be a failure. So you are widening the spectrum of potential issues there when using the request response model. Now let's enter the world of publisher subscriber pattern from a theoretical perspective first. Let's try to understand when we say message broker, what does broker? Why the word broker? Let's try to explain that, what happens internally in this Kafka, RabbitMQ, Amazon SQS, or Azure Service Bus. What happens in reality? You see, there is two ways of explaining that. The first one is on the top. You have the publisher application, which can be the ordering service in our use case example. And we have the subscribers, several subscribers. So the publisher send that message to what the message broker calls an input channel. And that message broker internally has several output channels where it hands those messages or it saves those messages for consumption, for interested subscribers to consume these messages. So probably a better view here is that the producer is the publisher as well, because you can use producer, consumer, or publisher, subscriber. Both are valid wordings. So the producer or the publisher send that message to the input channel. Internally, that message broker distribute this message to several subscriptions. Interested consumers, interested subscribers have to subscribe to that subscription to receive that same message and deal with that message in its own way. Each have its own concern. So that is how the message broker distribute or make sure the same message can be consumed by multiple subscribers from a high level perspective. Now let's see that same use case or how we can implement or solve the problems we spoke about earlier in the use case we have. That is the publisher subscriber pattern implemented for our use case. Again, we have the user submitting an order. The ordering service receives that order, do the necessary validation and business rules processing. Once everything is fine, that ordering service gonna submit. Instead of directly calling server to server that payment service in an HTTP fashion, it sends a message including that order payload in a JSON format, for instance. Then it returns directly to the user that your request has been received. Sure, it has its own database where maybe it create that transaction or order with a pending state, pending processing or something like that. That ordering service is free to serve several other request. It's not waiting anymore on the payment service to process your transactions. That is scalability, guys, for the ordering service. It can serve several thousands of concurrent requests following this approach. Fine. Now, the payment service, listening to that order-created topic or channel, listening to that subscription, receives that order payload, do the necessary validation, and submit that transaction to the external payment gateway. Now, several things can happen here. If the external payment returns a successful message, that message that includes a reference ID and all the other detail that any payment system returns, that payment service gonna create a message that include the payment details in another dedicated topic called payment received here, and continue serving or consuming other messages incoming from the ordering service, releasing its memory, releasing its processing, its computing capacity to serve more requests. All right? Now, what if this external payment goes down? For instance, that payment service has a possibility to keep attempting to call that external payments for a certain amount of retries without committing that message back to the message broker that it was processed successfully. So you win here the retry mechanism in a well implemented fashion. Now, if that payment fails for insufficient fund, for instance, that payment service can log that payment, the payment failure payload into a payment failed, for instance, topic as well. So you can decide how to process these failure in a separate process. Now, coming back to the happy scenario, that payment received here, successful payment, is to be processed by multiple consumers, multiple subscribers. Subscriber 1, subscriber 2, listening to the same message. The sales service here gonna consume that message and update its software as a service on the cloud. Similarly, the email service gonna consume that same message and coordinate or communicate with the SMTP gateway to notify that specific user via SMTP protocol on his email. So this way, you made sure that any failure on this pipeline processing is better handled, is gracefully handled. So that's the idea behind having a publisher and several subscribers. Removing the single point of failure dilemma we have in traditional architecture. Let's go now and see this in action implemented on AWS services first. You see, that's the same scenario, a desktop UI initiating an order creation request. It goes through the API gateway. A Lambda function, which is the ordering service, receives that service call that payment service, in this case, synchronously. That payment service communicates with the external payment, and then once it receives the response or the transaction success from the external payment, it communicates with Amazon notification service. That is where the publisher subscriber, or that is how AWS implements the publisher subscriber pattern. Once that Amazon notification service receives that payment successful received or failure, depend on the situation, you can see here you have a sales service Lambda subscribing to that notification, an inventory service as well, and that notification service can send email to the corresponding user as well. Each Lambda function subscribing gets the specific message. In this case, it updates its own DynamoDB, and the inventory service here updates its own Oracle database. So that's the first scenario, or the first cloud example, how Amazon implements that pattern through the notification service. Now let's go to another example from Azure using the service bus now. Similarly, the request going through the gateway, hitting the ordering service. Ordering service does the necessary processing. Once everything is fine from a business rules perspective or validation perspective, it logs a message into the order created topic under the service bus. There is a setup between the service bus and Azure function payment service here that trigger that function whenever a new message arrives. Once that function is triggered, it attempts to process this transaction through the external payment. Similarly, once that payment is received, another topic is created to receive this payment payload. Similarly to Lambda, to AWS Lambda, you have here three functions. The sales first subscribing to that topic to receive this message and update its software as a service cloud application. The inventory service receives that same message, acting as subscriber 2 to update its database, and the email service, in this case, subscribing to that same topic to send that message back to the receiving or initiating customer. That is how, using the service bus and Azure function integration, Azure give you the power of the publisher subscriber pattern ready for you to use. So that's it, guys. See you next time.